Okay, so this whole unit, okay, is all about conics. So conic sections are basically sections that are cut from a cone, and the pictures of all of them are shown as well. So your conic sections are circles, parabolas, ellipses, and hyperbolas. Hyperbolas. I always say the wrong word. Hyperbolas. Okay, most all of those words you've probably heard before. Maybe hyperbola you have not, but hyperbola is basically two parabolas shaped together and kind of forms like a rectangle on the inside. But we'll talk about that next class. Today we're just going to focus on parabolas and circles. Okay, you've seen circles before last year, yes? Okay. All right, so circles, or a circle, is a set of points in a plane that are equidistant from a fixed point. We agree? Okay. Your equation of a circle, remember, has a center at h comma k and has a radius of r. And your formula is x minus h squared, y minus k squared. And then that equals your radius squared. Okay. So if you were asked to write an equation of a circle with a center at -3, 4 and a radius of 6, this is my h and my k value. And this is my radius value, so I can plug these values in. So that gives me x minus a -3 squared plus y minus 4 squared is equal to r squared. So if I simplify that, I'm just going to leave that as x plus 3 squared plus y minus 4 squared is equal to 36. Okay, now if you were to sketch this on a graph, you would be at the point -3, 4, and then your radius would be 6. This point right here. And then we got a circle. Well, kind of worked. You get the idea. Kind of like went over my circle. That's okay. Okay. Next one. Write an equation of a circle with center at the origin and then the radius of 3 and state the domain and range. So what would my equation look like if we're centered at the origin, or 0, 0? Yeah, x squared plus y squared is equal to, what is my radius again? 3, so 9, right? That's your formula. And if you think about like what your sketch of that graph would look like, it's going to be centered here, and then it's going to go over 3 in all directions. So your circle is going to look something like this. So that means that both my domain and my range are going to go from the lowest point, or to the most left point, to the farthest right point, or the highest point, which would be what to what? -3 to 3 for both of them, right? Domain and range, both the same thing. Okay, now on the Delta Math assignment that you're going to have, the Delta Math assignment, sometimes it might give you the center of the circle, and sometimes it might give you the radius. If it does both of those things, it's a very easy problem, right? Other times it might only say that, like, let's say that the vertex is at, I don't know, -2, 4, and then it'll say it goes through the point, I don't know, let's call it like -10, or sorry, square root of 10, and then 7. Okay, if I think about sketching a picture of that, that's going through this -2, 4 point, and then the square root of 10, 7, we'll call that, like, let's see, something like this. So I know that my circle would look something like that, where this distance right here is what? My radius, right? So if I want to find that distance, there's kind of, two different ways you could do it. You could do the distance formula, but who really remembers the distance formula? Maybe you do, that's great, good for you. Or I could just think about drawing a triangle, right? Like if I zoom in on this distance, this vertical distance, changing from 4 up to 7 would be a distance of what right here? A distance of 3, right? Now this horizontal distance, I thought I was going to come up with a weird number, and I sure did. That's okay. But that horizontal distance would technically be, I'm going to change this number. I don't want it to be the square root of 10, because otherwise it's going to make our numbers kind of funky. Let's change it to be just 1, okay? So what is that horizontal distance from -2 to 1? Also 3, right? Okay, so if I want to find the radius, well, Pythagorean theorem says a squared plus b squared equals c squared, right? So this would be 9 plus 9 is equal to 18. So this distance is a square root of 18, right? Now when you're writing your equation of the circle, here's my vertex. So it's going to be from your standard form there of x plus 2 squared plus y minus 4 squared. But that's then going to equal my radius squared. So if my radius is a square root of 18, what is my radius squared equal? 18. Okay, does that make sense? When it's through a certain point and it's not just telling you the radius, you're going to have to do a little triangle situation there. Okay. These next two, okay, we're just going to actually do one of them. We will skip letter B. Last class said that you guys didn't really do a whole ton of completing the square, but I don't necessarily believe them. Do you guys remember talking about completing the square a little bit? Yeah? Yeah? No? Some of us? Okay. Hopefully going over this is a refresher for most of you, and if it's new, really, really, really pay attention, okay? So we're given something that's basically been FOILed out, or like it's not written in that standard form to find what my vertex is and what my radius is very nicely. So what we can do is we can rewrite this in the format of x minus h squared plus y minus k squared is equal to r squared, right? But in order to do so, we're going to have to do some rearranging, okay? So let's look at my x squared and 6x piece, okay? This stuff right here, is that enough information to change it into something like x minus h squared? No. So what we could do, though, is we could write x squared minus 6x, and then there's like a magic number we can add to this to make it so that it's factorable. Okay, the way that you get that magic number there is you take your b value, which is this -6, you divide it by 2, and then you square it. Okay, so if I would rewrite this, this is x squared minus 6x, and then -6 over 2, that's going to give me -3, right? But then -3 times -3 is positive 9, right? So now I've got x squared minus 6x plus 9. Could I factor that? Yeah, I could factor that into x minus 3 squared. And where you also get the 3 from is from your b divided by 2. -6 over 2 is equal to that -3, right? Okay, so that was just my x piece, but this is an equation, right? So if I added this 9 to the left side of my equation, don't I also need to add that 9 to the right side of my equation? Yeah? So I'm going to need to add a 9 to this side. Okay, now my y's, I've got y squared plus 10y plus 25. Now, could I factor that without having to do any completing the square? Yes. I could, right? That could just go straight into my answer of y plus what? How do I factor that? 5. Y plus 5 squared, right? And again, I did not need to add anything to both sides in order to make that happen. I already had the 25 there, so I didn't need to do any completing the square. And then we know that this is equal to now 9. So my center from this equation we can tell is at what coordinate point? Opposite. It's always minus h minus k, so it's going to be positive 3 and negative 5 for my center. And then my radius, what's my radius going to be? 3. Okay, we're going to do B. Okay, now if you notice in between these two, the a value or the term in front of that quadratic term is a 1, right? And it has to be a 1 in front of both the x and the y in terms of that standard form of the equation. So how could I get rid of the 2 that's in front of both the x squared and the y squared? Divide. Let's divide by 2, the entire equation. Yeah? So this now becomes x squared plus y squared minus 3x plus 5y. And then we also need to divide the right-hand side as well, so that's going to equal 1/2. Okay, so now let's rearrange this so that way we can actually complete this square. So I've got x squared minus 3x. And then I've got my y squared plus 5y. And that's all equal to 1/2. Okay, so I'm going to add something so that I can complete the square. So if I add my b divided by 2, that would be negative 3 over 2 squared. Okay, and now 5, if I add 5 divided by 2, and I square that. Now I can go ahead and factor both of those pieces on the left. But since I added those things to the left, now I also need to add those numbers to the right, correct? Okay, so this negative 3 squared, or negative 3/2 squared, what does that equal that I'm going to add to the right side? 9/4. So I'm adding 9/4. And then if I square 5/2, I end up getting 25/4, right? So now I didn't change any equality, right? They're both still equal to each other. And now I can go ahead and factor, okay? In your factor, it's always going to be x and then whatever that thing is inside the parentheses. So this is a minus 3 over 2. So this is going to be x minus 3/2 squared. And then plus y. And it's also a 5/2. So it'd be y plus 5/2. So it's that b over 2 value before you square it is what's going inside those parentheses there. Are we okay with that factoring piece there? Okay, and then on the right-hand side, let's just go ahead and simplify this. So this becomes 2/4, and if I add 2 plus 9 plus 25 together, that gives me 36/4, right? Which really, that's just 9. So now from here, we know that my center of my circle is at the point 3/2, comma negative 5/2. And my radius, on almost all of these ones on the front page, what's my radius going to be again? 3. Okay, so the basics of parabolas that you guys have seen before are mostly just like the formula of y is equal to a times x minus h squared plus k, right? That's usually what you see for your formula for parabola, okay? We're going to like take it down, or take it up a notch, I should say, and talk about this thing called the focus and the directrix. Not sure if you've heard of those words before. I think they are new. I'm going to show you it's actually a link in Schoology, but it's a visual of how and why those two things are helpful in order to figure out points on your parabola. So a parabola's definition, similar-ish to a circle. However, a parabola is a set of points that are in a plane that is equidistant from your fixed point, which is your focus, and then your fixed line, which is called the directrix. It does kind of sound like a Harry Potter word. So I'm going to go quick and pull up the video and show you what this it's basically a bunch of triangles is what's happening. It's a bunch of geometry. So your equation looks a little bit more complex here because we're talking about things that aren't just like, the most you guys really would do is like a number with a 2 in front of it, and it would be like 2x squared. But for the most part, your like a value is always 1 for your parabolas. So this time it's not always going to be a 1 value. So if you look here, this is your equation, okay, with either x's squared or y squareds. Now if my x's are squared, then it's going to be your parabola shaping up or down, right? Where a c value is positive, so that value right here is positive, or your c value is negative if it's upside down. Yes? Now, if my y values are squared, which direction is my parabola going to open? To the side, right? So if it's a positive c value, we're going to open to the right. And then if it's a negative, we're going to open to the left. Another thing that I would like to add on there is that the 4c value, that is what we call our focal diameter. And what that means is at your focus point, if you were to connect a line that touches both endpoints and the focus, that is what my focal diameter distance is, okay? Now the cool thing about your focal diameter is, let's say that this distance is 10. If that distance is 10, that means that half of that distance is 5, right? And then the cool thing about this relationship with the focus point distance is that this is also half of that. Kind of cool there. Bunch of triangles, bunch of geometry. Yeah, I chose a number that didn't go in half twice nicely, but that's okay. But yes, it is half of that 5 value, so it'd be 2.5, okay? So these first two examples, we're just trying to figure out what the focus, directrix, and vertex is based on the formula that we should be using. So example A is x squared is equal to 8y, so that's using that first formula. And if I would rewrite that in terms of that formula, that's technically like x minus 0 squared is equal to, I want to rewrite 8 to be in terms of 4 times c. So this value 8 is equal to 4 times c. So what is c going to equal? 2. So I'm going to write this as 4 times 2 times my y minus 0, because that tells me that that is my c value, and my c value tells me where my where my focus is and where my directrix is going to go. Okay? So I think the easiest way to kind of think about this is to sketch a picture. So if I sketch a picture of my graph, okay, where am I centered at? Centered for my vertex here is pretty easy to see. 0, 0, right? So my vertex, that's one of the things we're finding. That is at 0, 0. Also, we know that it's x squared. So if it's x squared, that means we're going to have our parabola shaping up or down. It's up because that value of c is positive on the right side there, okay? So I know it's going to look up something like that, okay? My focus is the distance away from the vertex in relation to where the parabola is opening. So if the parabola is opening up, my focus is going to go in that direction as well, and my focus is up a distance of 2 from that point. So your focus would be at 0, 2. Okay, my directrix is in the opposite direction. So my directrix, instead of going up 2, it's going to go down 2 from that vertex. And that line right there is my directrix. So your equation of that line would be y equals -2. Now this one's nice because it started at 0, 0. So it's adding 2 and subtracting 2 from 0, right? Now that vertex point might be at a different value. It might be at like 1, 4. It might be at 3, 6, right? So your focus is going to change and your directrix is going to change based on where that where that vertex point is. And then the last thing I just want to point out is your focal diameter up here again. This focal diameter is that 4 times C value. So if I zoom in on this picture here, what it's saying is this distance from this point on the parabola to that point on the parabola going through that focus, this whole distance is 8, right? Half of that distance is 4. And then half of that distance is my distance from my focus to my vertex. So 2. So this is 2 times it again to give you one side, times it again to give you that entire focal diameter. Okay, do we see that? Okay. And then axis of symmetry right here. My axis of symmetry is going to be exactly on that y-axis there, right? If I split it in half, I'm going to have the same left side as I am the right side. Now that axis of symmetry might shift. It might be like a line x equals 3 if it's been shifted over, right? But it's going to have that same either x or y value based on where your vertex is, if it opens up or if it opens to the side. Okay. All right, let's look at the example B. We've got y squared is equal to -28x. So if I'm sketching a picture here, I know it's y squared and it's negative. So normally y squared opens to the right, but since it's negative, it's going to open to the left. Okay, so kind of a little quick sketch here looks something like that. Now I'm going to use that y equation formula up here. If I would rewrite this in that form, it's y minus 0 squared is equal to, well, let's see. We want -28 to be equal to 4c. So 4c equals -28. What is c going to be? -7, right? So I've got 4 times -7 and then times x minus 0, which is just x, right? So there is no change of my vertex here. It's still at 0, 0. But this c value is -7. So my focus, if my vertex is at 0, 0, my focus is going to go left 7, or in the direction of where the parabola opens. So I'm going to go left 7 here. 1, 2, 3, 4, 5, 6, 7. So that point right there is my focus. And that would be at -7, 0. Okay. My directrix is going to go in the opposite direction. So I'm going to go +7 and draw my line. So my directrix would be at the line x equals 7. What is this parabola symmetric about?
Y-axis.
The y-axis in this case. Okay. And then again, my focal diameter, if I would to connect these 2 points through that focus and touching both endpoints, that entire distance is 28, which means half of that distance is 14, which means the focus distance to the vertex is 7. You see that? Whole thing's 28, split it in half again, gives you that focus. Okay. All right, last example, because we are actually skipping example 3. And we're going to look at 2. Okay, write an equation for each parabola given the following information. I'm going to change this up a little bit because the ones on the Delta Math aren't always as nice as giving you the vertex on the origin. So we're going to do one. It's not as, it's not terribly tricky, but you do have to draw yourself a picture. So the problem that I want us to do is it's going to go through the point, your focus is at the point 10, -3, and the directrix is at x equals -6. And we need to write an equation for that parabola. Okay, so we gotta draw a sketch. So 10, -3. Just gonna kind of sketch that right here. So we'll call that 10, -3. That's my focus. Okay, my directrix is at x equals -6. So we'll call that -6 there, so I can draw my line. That's my directrix. Now, I wasn't even given a vertex. How am I going to find my vertex if I know my focus and I know my directrix?
Equidistant.
It's equidistant, right? So if this is at -6, right, we can think about this point being at -6, -3. So what is the distance total between these 2 points? Between -6 and 10. That total distance is 16, right? So halfway would be 8. So 8 units away from the 10 would be at the point what? 2, right? So this point is at 2, -3. Okay, so we know our parabola opens up towards my focus point. Okay, my C value, the way I find my C value is that distance between the focus point and the vertex. So we talked about how this distance right here was 8, right? So that's my C value. And then when I'm plugging it into my formula for opening to the right is y minus k squared is equal to 4c times x minus h. So I just got to plug in my vertex point. So I've got y minus a -3, so really it's y plus 3 squared. And then 4 times c, well, my c value is 8, so that would be 32 times x plus 2 minus 2. Okay, again, reminder, if you know that this is 32, that's your focal diameter, so this whole distance going through the focus would be 32, which means that half of it would be 16, and then another half of it would be 8. Okay, so if you're given any of those like 3 pieces of information, or if you're given that the directrix is so far away from your vertex, you should be able to find the rest of those things, right? Does that kind of make sense? Yeah? Okay. Let's do one more example and then we'll be done. Letter B. Letter B says that our vertical axis, this is the symmetric line. Symmetry is what I was trying to write there. That's our line of symmetry. Our vertex is the origin, then it's going through the point -2, 12. Now that's not like that's on your focal diameter or anything like that. It's literally just the point. Okay, so if I'm drawing a sketch of this graph, I know my vertex is here, and then it's going through the point -2, 12. So my sketch of my graph looks something like this. So I know it's facing up, which means x squared or y squared? X squared. So I know it's at the vertex is my origin, sorry. So I can go ahead and say x minus 0 squared is equal to 4c times y minus 0. Okay, now do I know anything about my focus or my directrix to help us figure out c? No. So the only equation that I have so far is x squared is equal to 4c times y, right? What are we going to do now? Use our brains. How do I find c? What am I given? But if I divide by 4y, then I still have variables, right? We're given a point, right? If we're given a point, can I find c? Yeah, let's plug that in. So -2 squared is equal to 4 times c times 12. And then if I solve for c, I get 4 is equal to 48c. So this would be 1/12 is equal to my C value. And all I gotta do is just plug that value back in, 1/12 back in for C, to give your final formula of x squared is equal to 4 times 1/12 y. Or I could simplify one more time and say that that is 1/3 y.